Our next lesson is called Real World Applications of Volume. So we'll start with this chart. It says for each figure, list 2 real world items that represent the figure. If you'd like to think about this on your own first and try some, you could pause the video and then resume to see if there are any similar ones to me, and you can add mine to your list as well. So for a cylinder, a couple things that are in real life that make me think of a cylinder is any type of can, like a soup can. And I could also see something like a science beaker, where you kind of pour liquids into it and use it in an experiment. For a cone, I had an ice cream cone. I also thought of a traffic cone, the orange traffic cones you see when driving. And for a sphere, I had a basketball. Of course, that could be soccer ball as well, volleyball. And I also thought about social studies and how we use a globe to look at Earth. Are there more examples? Obviously. But these are just a few that if I saw them in a problem and the shape wasn't specifically named, I would know that, for example, if it's talking about a can full of soup, I know it's a cylinder. If they're talking about a basketball being filled with air, I know that's a sphere. So today we are going to work on problems, real world problems that have to do with volume. If you're in class, you'll be completing this in numbered heads together. If you're watching this with me to make up the lesson, we're just going to go through the problems together. So the first question says, a box contains 9 identical glass spheres. So this one is actually telling us exactly the shape. We're dealing with spheres that are used to make snow globes. So again, if I didn't see the word spheres and I saw snow globes, I would still know I'm talking about a sphere. The spheres are tightly packed as shown below. So it's almost like there's a box container, and these 9 spheres have been packed inside where all of the edges are touching the box. You can see the box has dimensions of 12 inches by 12 inches. And they want to know what is the total volume in cubic inches of all 9 spheres. So that's important. We want all 9. It says round your answer to the nearest tenth of a cubic inch, which tells me they're looking for an approximate answer, not exact. Now, they gave us the volume formula right in the problem, which is nice as a reminder. We're obviously going to have to use that. Now, we're talking about 9 different spheres. I'm just going to have to focus on finding the volume of a sphere first. Now, looking at that formula, remember the only dimension that we need to calculate the formula for the volume of a sphere is the radius, or r. So if I go up and look at my picture, I don't see any radius labeled in any of these spheres. But I do have other information in the picture that would help me. So for example, if I let's focus on the front of the box here, I technically see there are 3 spheres tightly packed across that. So I'm going to draw a line right through the center of them, parallel to the bottom, because it's the same exact line. But by moving it up, I can see that it slices through all of my spheres. So if this whole thing is 12 inches, I see 1, 2, 3 spheres that tightly fit across that. So I'm going to take that 12 inches and I'm going to divide it by 3. If I do that, 12 divided by 3 is 4 inches. That tells me that from here to here is 4 inches. From here to here is 4 inches. And from here to the edge of this sphere is also 4 inches. Now, looking at the picture, that 4 inches is the distance all the way across the sphere. So what I've actually found is the diameter. The diameter is 4 inches. You know, for the formula, we don't need the diameter. We want the radius. The radius is going to be only half of that diameter. So half of 4 would be 2 inches. My radius is then cut in half from the diameter. So I know it's 2. So now I have what I need in order to put it into the formula. So now we can find the volume of a sphere. So volume is 4/3 pi r cubed. 4/3 pi, and our radius is actually 2. We know that now, so I'm going to put 2 in, and it's going to get cubed, which means this is 4/3 pi, 2 cubed is 8. So now I can do 4/3 times 8, and I'm just going to leave it in terms of pi right now. I'm going to get 32/3 pi. Now, I know they want me to eventually round it to the nearest tenth, but I'm thinking to myself, this is only the volume of how many of the spheres? 1. How many spheres do we actually have in our picture? 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, 9 identical. So there are actually 9 spheres, which means the total volume is going to be taking the volume of one of them and multiplying it by 9. So I waited until now to type it into my calculator and get the volume approximately. It is 301.5928, continues on your calculator. But remember, they wanted the volume to the nearest tenth. So that's this place. We look next to it. 9 is definitely 5 or larger, so that's going to bump our 5 up to a 6. So now we know that the volume of those spheres is approximately 301.6. The units were inches, and since it's volume, it should be cubed. So there's our first real-world problem. Now let's go on to another example of a real-world situation in number 2. An above-ground swimming pool in the shape of a cylinder. So even if I didn't know it was a cylinder, think about a swimming pool. Traditional above ground is cylindrical in shape, so it's a cylinder. So already I know I'm working with that formula. They gave me a diameter of 18 feet and a height of 4.5 feet. If the pool is filled with water, so filled with water means we're talking volume, but it says 6 inches from the top of the pool. So think about this. If you're filling the pool and people are going to swim in it, you don't want to fill it all the way to the top because then the water will come out. So they're going to leave 6 inches at the top of the pool without any water. They want to know what is the volume to the nearest cubic foot. So that's the nearest whole number, okay, of the water in the pool. Now, if we think back to some of the other tips and strategies we talked about, it's important to figure out what formula you're using, what you know, what you don't know. And if you remember, one of the things we said to look for is if your units actually match. So I want to go take a look at the units. Diameter is in feet. Then I see the height are in feet. So far, so good. But then when I look at how much is left on top for the pool, it says 6 inches. So I notice that my units don't match. So we have some work to do. So let's talk about the diameter first. That's what we were given first. We have a diameter of 18 feet. Now remember, the radius is half of the diameter, if you recall from before, half the diameter. So if I'm doing half of 18, that means my radius is actually 9 feet. So that's important. We got one of the things we know we need. Because we are working with a cylinder, we've got the formula V equals pi r squared h. And we have the r that we now need. Now the height. The height of the pool itself is 4.5 feet. So I'm going to come over here and write that down. But then they told us we're not going to fill it all the way up. We're going to leave it 6 inches from the top. Now, this is where we had an issue with units matching. Currently, I've got 6 inches when everything else is in feet. So I'm going to think up to myself, how do I change inches into feet? Well, how many inches are there in a foot? There are 12. There are 12 inches in 1 foot. So 6 is half of 12, which means 6 inches would be equal to half a foot. So the height that I actually need to use is the height of the pool minus the part we're going to leave without water, which is 0.5, the 6 inches. So that means the height I'm using is actually 4 feet. So now I have everything that I need in order to actually find out how much water is going in the pool. So we have equals pi. Our radius is 9. So I'm plugging that in. And our height is 4. So that's pi. 9 squared is 9 times 9, which is 81, times 4. Now, they said they wanted it to the nearest cubic foot. So I'm going to have to get a decimal and do the appropriate rounding. So at this time, you'd plug all of those values in your calculator. They're all next to each other. So that's pi times 81 times 4. And you get approximately 1017.87602 ... It's going to keep going. And we want the nearest cubic foot, which means we want the nearest whole number. So we're actually looking in the ones place. I'm going to look next to it and see that 8 is definitely 5 and above. So that's going to bump our answer up to 1,018. This is volume measured in feet. So that'd be feet cubed. Now for our last problem. A company makes 2 different size ice cream cones. So ice cream cones, definitely a cone. The smaller cones are 3.5 inches tall and have a diameter of 3 inches. The larger cones are 5.1 inches tall and have a diameter of 4.5 inches. About how much greater to the nearest tenth of a cubic inch is the volume of the larger cone than the volume of the smaller cone? So I'm going to draw a couple diagrams to help us out here. We have a smaller one. So I'm thinking ice cream cone kind of looks like this. The diameter is 3. So this is diameter. That's important. The height is 3.5. Then we have the larger cone. So just draw it slightly larger to keep that in mind. The diameter here was given as 4.5 inches. And the height for this one was given as 5.1 inches. So, again, we have to think about what we were given. These are diameters. I know if I'm going to start finding the volume of cones, my formula is V equals 1/3 pi r squared h. I need a radius and I need a height. So I have the right height. I don't have a radius right now. I have diameters. So remember, diameter, if you cut it in half, gives you the radius. So half of 3 is 1.5, and half of 4.5 is 2.25. And then remember, we already had the height here was 3.5, and we already knew the height here was 5.1. So now the question is saying to us, how much greater to the nearest tenth, so that means approximate, is the volume of the larger compared to the smaller. So I've got to find the volume of each of these things and then figure out how much more the one larger one can hold. So I have a couple of volumes I have to find. I've got to find the volume of the smaller cone, and I have to find the volume of the larger cone. So the smaller, we're using our formula 1/3 pi r squared h. We're going to rewrite what we know, but for r, we're going to put 1.5, and that's going to get squared, and then times it by the height, which is 3.5. So that's going to be 1/3 times pi. 1.5 squared is 2.25. And then we have our height of 3.5. So if we do that on our calculator, including pi, we're multiplying all of these things. So 2.25 times 3.5 times pi, and then also times 1/3. We end up with approximately 8.246680,716. And of course, that would continue on. So we're going to leave it for now because remember, we don't want to round until the very end. We're also going to find the volume of the larger cone. So 1/3 pi r squared h equals 1/3 pi. Our radius of the larger was 2.25. That's going to get squared. And our height is 5.1. So here we get 1/3 pi. If I do 2.25 squared, I get 5.0625 times 5.1. So again, this is all multiplication. So we're going to do the 5.1 times the 5.0625 times pi, and also times 1/3. So we end up with approximately 27.037333177. Is going to keep going. Now, thinking back to what the question's asking about us about how much greater. So when you see how much greater, I need to know the difference between them. So that means we should be subtracting. And keeping in mind what we've talked about before, another star, we don't want to round until the very end. So round at end. So we're going to finish this up. We're going to take the larger and take away the smaller, which means we're going to take that 27.037333177 number, and we're going to subtract the 8.246680716 number. And we get approximately 18.79065,106. And remember, they wanted it to the nearest tenth. So this is the tenths place. We look one past it, and we see that the 9 is going to make our 7 bump up to an 8. So this is 18.8. And we wanted to know how much volume more it held, right? So this is 18.8 cubic inches larger than the other one. And then we can circle our answer. And that concludes our lesson on real-world applications of volume.